Hello students, welcome back. Let us resume our discussion in section 2, example 2.3. We completed the first problem here, part A. Find this quantity. Well, whatever expression, the key point is to find out the function value for given x value. In this particular case, we have to find out three function values, f of 4, f of 2, and f of 6. How do you find those? Start from the x-axis and start from appropriate x-coordinate value on the x-axis. For example, when x is 2, start from here and then move vertically until you hit the point on the graph. Once you hit it, what's the y-coordinate? You can move horizontally to find out. Why do you work vertically? That's because all the points on the vertical line share the same x-coordinate. So you're going to stick to x is 2. That's why you're moving vertically. Once you find out the point on the graph, now you're going to move horizontally because every point on the horizontal line shares the same y-coordinate value. You're going to find out y-coordinate value of this point, so you can move horizontally until you hit the y-axis, and that's going to give you your y-coordinate value. Same here, start from 6. Got the point, and then move horizontally. Move vertically, and got the point, and move horizontally like that. Now let's consider opposite direction. Solve the equation f of x is 3. In other words, find all x-coordinate values such that f of x is equal to 3. Here, x values are known, 4, 2, and 6, and we have to find out y-coordinate. This time, we have to find out x-coordinate. Find all x values. And what's known here? F of x is 3. But look at the graph. Y equals to f of x, right? So that means y value is 3. See what I'm talking about? Y equals to f of x is a graph, and that's 3. In other words, y-coordinate is 3. And then we have to find out x-coordinate values. There can be 1, there can be 2, there can be many, maybe there can be nothing. It depends upon which y-coordinate value we begin with. Y-coordinate is 3, so let's begin with y is 3, like this. Okay, y equals to 3 is this horizontal line. So y equals to some number, that's a horizontal line, in this case 3. So they all share the same y-coordinate value, 3. And then we have 3 crossing points, one here, oh, not this one, just 2. This one here, and then this one is not a crossing point. This point is emptied out. The real point is down here, so it's not a crossing point. So not this one, no. Beware of this empty point. So there are 2 crossing points. So 2 points on the graph. That means 2 x-coordinates to consider. This one right here will give me x value 0. And this one is going to give me x value 6. So that's 0. And that's 6. Oh boy, it's really lousy graph. Let me get out of here and then open up my answer key. Okay, that looks better. Horizontal line y equals to 3. And then we have 2 crossing points. One here, and then another one there, and this one is bogus. X is 6 here, and x is 0 there. And that's why we get these 2 solutions. Now, what if you have different f of x value? For example, what if you have this problem here, which I'm copying and pasting and adjusting. Ooh. So not this. Let's see, call it b star. Okay, alright. Solve the equation f of x is 4. Okay, we need y equals to 4. In that case, we need this horizontal line. Y equals to 4 right here. And we have a crossing point here, the second crossing point here, and then the third one right here. So this x-coordinate something, and this x-coordinate again is going to be an estimation, and then this x-coordinate. Looks like that's what you'll have to do. So what are those x-coordinate values? Any reasonable estimation will do. Here I'll do about 0.5. Yeah, about 0.5. That'll do it. And then this one about 3.5. Is it 3.5 or 4.5? 3.5 is right. Make sure you count correctly. And this one 7.5. Well, it doesn't have to be accurate, so let's just use 0.5 for everything. But anything reasonable will give you full credit. Even if you write 3.3 or 3.7 or whatever, it's going to give you full credit. Don't worry about it. If you use, say, for example, 4.2 or 5.6, that's not going to count. 4.2 is just a little bit, but 5 or something, clearly this is between 3 and 4, you see. So in some cases, you'll have to do some estimations. In some other cases, you may end up with no solution. For example, what if you have f of x is equal to, say, 0? Okay, f of x is equal to 0. So y-coordinate is 0. So you're looking at this horizontal line. Y is 0, so it's x-coordinate x. Let's get out of this drawing. I don't know what's happening here. I don't know what I clicked. Well, looks like I'm back. Let's try again. No. Oh, I see. Okay, alright. Okay, so y equals to 0, same as coordinate x. Never mind. Okay, let me try just one more time. Okay, this line, which is y equals to 0. Okay, alright. And then there's no crossing. So in this case, the solution set is an empty set. There's no solution. This kind of thing can happen. You can have 2 solutions, or you can have 3 solutions. You can have 1 solution, or you can have no solutions. You can have 5 solutions, depending upon what the shape of the graph is. You can have all kind of things. Okay, so much for the variation of B. Now let's go to part C. Solve an inequality. F of x is less than or equal to 3. Well, we went through f of x is equal to 3 or y is equal to 3. So it's got to be similar. But this time, y is less than or equal to 3. So y equal to 3 is this line. This one here, y equals to 3. But y is less than or equal to 3. So is it above or below? Y-coordinate is less than or equal to 3. So we have to look at down below. And above that, you have to discard all those. So just look at down below. And what part of the graphs are down below? Do you see that is this part of the graph and this part of the graph? I should have used different color. This part of the graph and this part of the graph. Those are important, and the other two parts up here, all those will be discarded. Now, for which x-coordinate values do you get this part? Greater than what? Less than what? See that? At which x-coordinate value do you get this part of the graph? Greater than what? Less than what? Let me show you my answer key. Here we go. Y equal to 3 is this horizontal line, and we have to consider y value less than or equal to that. So we have to consider this portion of the graph and that portion of the graph highlighted in blue in this green region. Up there, you have to discard those. And then for this curve, what x-coordinate value? As you can see down here, between -1 and 0. And for this curve, x has to be between 4 and 6. Do you see that? Consequently, x belongs to the union of these two closed intervals, -1 to 0 and 4 to 6, union of those. Visualized as a -1 to 0, union 4 to 6. They are both closed intervals because we have semi-inequality here, so we have solid dot. Yeah, that's part of the interval, part of the graph. And then here we have solid dots. That's part of the original graph. So the solid versus empty dots are going to add a little bit of subtlety, but otherwise we have inequality, and that is basically above or below a certain y-axis. I mean, above or below a certain horizontal line, y equals something. You can consider between two horizontal lines and consider a strip. You can consider various situations using inequalities. It was actually many years ago when I wrote this kind of things, a student asked me about the usefulness or validity of this kind of problem. Hey, what's the motivation? What do we use these kind of things? It looks like totally arbitrary. It is not. To that student, I showed a graph of Dow Jones Industrial Average, I think, or S&P 500 or something like that, because it was business math course, as a matter of fact. So let's go here and let's see. Okay, let's go to Dow Jones. So this is a stock market for those some small number of companies form this Dow Jones Industrial Average. 2 year to date, okay, we have a lot of fluctuations here. And then from year to date, when was Dow above 40,000? Okay, in that case, we have to consider, it's terrible. You have to consider this portion of the graph and also this portion of the graph. So you're going to get a couple of intervals and union of those. So from here, you can get approximate dates as well. If you have all those detailed data, you're going to get a bit better picture about when to when and when to when. And you should be able to see these kind of things and communicate with your client. And there are many other examples too. In medical science, we may have some reactions of some body, some hormones, and again, some kind of drugs. There are all kind of graphs out there, and you should know how to handle those. These are important. Especially when you step outside of classroom, graphs are extremely important. You may end up forgetting nearly all of those, but if you remember graphs, you can still say college algebra was a success, actually. I'm not exaggerating. Graphs are that important.